Hey everyone! So, sorry it's been a little bit since I made a little video here. And also, as you saw my post prior, I made a boo-boo when I ordered, let me grab this up, my logic analyzer. You can see I have it. But I did not order the wire harness that has clips so I can actually hook it up to an active circuit board. So, I had to order that. That was going to be my video I made, but we're going to go ahead and just try to keep things moving the best we can in general until those come in, and just look forward to a logic analyzer video. But until then, I'm going to do a review and show you how one of these cool Elenco, however you want to pronounce it, Electronic Playground 130s works, and show you how to do some of the experiments inside of it. I bought this for my son probably, gosh, I want to say 6 years ago, if not almost 10 years. It's definitely pushing 10 years. But, you know, he used it for a little bit, and it just got put on the shelf, and I decided, hey, why not? Let's show off how these cool little learning centers can work by teaching people about electronics. And I'm not going to lie, it's very, very basic, but it is a great starting point for people who don't know anything about electronics, or if you have a child who wants to learn about electronics, okay? So, if you're ever interested in teaching your kid, or even yourself, I mean, if you're an adult, who cares? This is a great way to start learning about it. This is a good device to get. So remember, the Elenco Electronic Playground 130. They sell for about 60 or 70 bucks online. That's not very bad. And they teach you a lot of stuff. You know, like if you look at it, not only does it have a bunch of components built directly into the board itself with these little springs. These springs are how you attach your wires to jumper them from piece to piece, okay? But it even has all the diagrams, like the schematical diagrams of all the different things you're doing. So, not only can you understand how different types of circuits work, you're also learning about the symbols used in electronics. And with the manual that comes with this, it actually teaches you about the basics and some advanced stuff when it comes to specific components, like your transistors, your capacitors, your diodes, your ICs, and so on. And that just kind of gives you the good starting point to understand it. Not only that, the manual itself actually shows you the schematics. And by that, I mean the manual that comes with this thing. It's a thick book. Look at that. It has a lot of experiments and everything inside of here. I mean, look at this. You got schematics built in. In the early stages, they actually show you the physical device you're using, so you know how to put the wires in, with the schematics on top of it. Plus, it's teaching you the symbols as well. So, this is a pretty handy tool, especially if you want to learn a little bit more about electronics and do some experimentation. So, let's get you set up, and I'm going to show you how to get this set up, and we're going to go ahead and go through the manual a little bit and do an experiment, maybe 2 or 3. We'll see what happens. Alright, so I'll be right back. Okay, so now that we're a little set up here, the first thing you need to do once you go ahead and get your electronic playground pulled out is you need to install batteries. So on the back side, you're going to see some battery holders. Now, as you can tell, it takes 6 batteries. We need 6 AA batteries. Now, I'm not using the fanciest batteries of all time, okay? These will just work for now. And if you figure it out, each battery is 1.5 volts DC. So when we multiply that by 6, we're going to get 9 volts DC, alright? That doesn't mean that the device is going to use all 9 volts, But having that extra voltage and all that is going to make things work a little more smoothly, okay? Now, we got our batteries installed. What I want to mention to you is some of the things that comes with this little learning center. And of course, like you saw before, it comes with a manual, a very thick manual, by the way. I mean, this thing, when it comes down to the last page of projects, is 152 pages. See that? Now, I mean, the manual in total is 159 pages because at the very back, you actually have a resistance chart, you know, identifying characteristics of capacitors, and then you have your metric units and conversions and such. So, like, it has some cool things with it. It helps you get a good head start in it. The other thing it comes with, which, by the way, I put these all in a Ziploc bag because I bought this thing years ago, is jumper wires of multiple different lengths. You have extremely long wires and extremely short wires and stuff, and they all have been clipped off and tinned on the ends there. I know it's going to be really hard for me to get a focus on that, but you kind of got to trust me. It's been tinned, and that's because when you move one of these springs over, you put the wire inside one of the spring slots, and you hold it down, and there you go. You got your connection, okay? Not everything needs a super long wire. There are sometimes you're jumpering from like a very short position, and you're going to use a shorter wire for that. And there are times you're going to jump from a long position to another long position, like basically almost all the way across the board, which you need a longer wire for. Okay? Now, before we get started on the first lesson for this, let's go ahead and look at this board a little more closely and see the different types of components and parts that we're going to be working with. Alright, for starters, we have a transformer. And of course, as you can see, it has the symbol that you're going to find in a schematic for a transformer. That's another nice thing about this device. It shows you the physical schematic symbols that you're going to see in real-life applications. And of course, we have our speaker with our speaker inputs with our speaker symbol. Again, everything's going to have a symbol that you're going to find on a schematic. Then we have a digital display. We have our control, which is basically what the symbol here is, a VR, or a variable resistor. So it's essentially a resistor that you can adjust the resistance coming out of it. So you can kind of think about almost like a volume knob, for example. Alright? Then we have our batteries, okay? Our bottom two pins here, 121 and 124, those are our grounds or our negatives. And then of course we have 119, 122, 120, and 123. Those are our positive inputs, but they have different voltage outputs, essentially. So your upper ones, 119, 122, those are your 4.5 volts. And then your lowers are your 1.5s. And of course, they can be combined together. So you can either have a 1.5 volt, a 4.5, a 3 volt, or a 9 volt. Okay? Now moving over, you can see our radio circuits and our controls. Now, this would be considered a variable capacitor, even though it's essentially a coil that's wrapped over a ferrite rod. That is one of the ways that we adjust the radio frequencies that we receive for a radio circuit. Okay? Then up here, you see a CDS cell. Now, a CDS cell is basically a light-sensitive diode, or a light-sensitive resistor, I'm sorry. And what that means is, depending on the style, it's either the more light that's applied inside of the cell, the higher the resistance, or the lower the resistance. And it depends on how it's, manufactured and designed, okay? But it's basically the amount of light that's coming to it adjusts the amount of resistance that it outputs, alright? Then we have our LED circuitry. Now, an LED is just a diode that uses the current that's passing through it to emit light, otherwise known as a light-emitting diode. Alright? Next are our transistor banks. We have the two most common types, the PNP and the NPNs. Alrighty? With the symbols too. Your base, your collector, and your emitters. Over here, we have our diodes. Again, a diode is basically kind of like a check valve. It only allows electrons to flow in one direction. It doesn't allow it to flow backwards, which could cause problems or damage to other components within the circuit. Down here we have a switch. This is used for variable different things in the program itself. A switch can also be used for so many different things. You know, this is just more basic idea. Then we have our different types of capacitors, okay? We have our ceramic style capacitors and our electrolytic style capacitors. There are multiple other types of capacitors like tantalum, for a quick example, that aren't on here. But those are for more advanced electronics, alright? Then we have our key, and the key is just your basic momentary switch, okay? Essentially, you have, if you don't push the switch, you leave it like that, you have an open circuit if this is being used. You push the switch, you close the circuit, alright? Basically making connection between this point and that point. Then, we have our resistor packs, and they're all just various different values of resistors. Another thing to note, remember that little horseshoe kind of shape right there? That represents ohms. So 22K ohms means 22,000 ohms. That's what that resistor's value is. In another video, when we start talking about different types of symbols that you'll find in the schematic, like capacitor symbols and resistor symbols and so on, I'll also be talking about resistor values and how to read and understand the value of a resistor based off the band colors that are on them. Next to that, and the final point, is our terminals. And again, the terminals are going to be basically used for various different things. It depends on the circuits that are being used in this particular learning center, okay? So I'm not too worried about trying to explain too much more than that, because it's going to depend on what project we're going to work on if we use these terminals. And that goes for everything in here, okay? Like, you know, you see your ICs, you have your integrated circuit, and your dual op amp. Your dual op amp, by the way, that's part of a sound circuit normally, because the amp, that kind of gives it away. And then of course you have your integrated circuit, which is a quad 2-input NAND. Remember, this is a NOT AND gate. So we have the AND gate symbol with the bubble on the end, which means that it's inverted, okay? So that's the basic layout of the Elenco Electronic Playground 130. Now from here, we're going to go ahead and look in our manual, and we're going to find us a little project to work on. Maybe we'll do one, but we could possibly do 2 or 3. It just kind of depends. Just to give you an idea about what this thing can actually do. So let me get you set up on the tripod, and we're going to start going through this manual, and you'll see what it has to offer. Alright, see you in a sec. Okay, so now I'm going to show you the manual that comes with this Electronic Playground and Learning Center, okay? So, like I mentioned before, it's a really thick manual. You can see this right here. This thing has got a lot of information and a lot of cool teaching techniques in here. Basically, of course, like most books and manuals, you're going to have your index here that shows you where you go. And, you know, some of you are going to call it table of contents. Then it shows how you install your batteries, which I already showed you how to do. Then it talks about, like, the connections, alright? This is how you actually connect the wires into the springs. That's what it's talking about. And that little part there, it's showing if you use the wires enough and they start to like break or fatigue, where you don't have proper connections, it shows you how to like strip the wires down so you can use them again, okay? The next part, it goes through all the various different types of components and stuff that are within this actual learning center thing. So, you know, you have your resistors with the resistor symbols, and then, you know, your variable resistors, and so on. Capacitors, transistors, diodes, capacitors, everything you can think about. You know, it's all right here. As well as a little bit of information about it. So, like, just for a quick one, I'm not going to go through each and every one, but let's look at the LEDs, right? Light emitting diodes. These are special diodes because they give off light whenever electricity passes through them. The current can only pass through in one direction, similar to a regular diode. Okay, and you can see the diode symbol there. The major difference is it has a circle around the triangle and the line, and then you have two arrows pointing out, which represents light that's being emitted, light emitting diode, okay? So that's kind of like the basics to this book. And of course I believe it continues. Yeah, it does. It continues on with the various different types of components that are in here with the symbols you're going to find on schematics, alright? Then towards the bottom part on page 9, you're going to see your first project, right? And what this is talking about is the example about how you set your wires and hook your wires up. So for a quick example, when you see these number tables like this, like 1-29, 2-30, so on and so forth, what that means is you're taking a wire and you're connecting it to number 1 and running it to number 29. Number 2 goes to number 30, number 3 goes to 104, 104 goes to 106, so on and so forth, okay? That's giving you a basic idea about how to read and understand this book for hooking up your different types of circuitries. And of course, it has a troubleshooting section. So, you know, if you have problems with your entire unit, you can try to figure it out yourself before you have to call the company and figure out what could be going wrong with it. And of course, they have suggestions and everything like that as well. Now, since we have the idea about this and got the start to the book, let's go ahead and actually start playing with our electronic circuits here. So the playground of electronic circuits is our first section. And as you can see, when it comes to our very first section, not only does it talk about the experiment, like we're going to do this one together. Experiment number 1 is called the Woodpecker, alright? Now what we're doing is we're making a circuit that sounds like a woodpecker chirping. And all you need to do is follow the directions with the wire sequences in order to make it happen. It talks a little bit about how the circuit kind of works. Like for example here, when you hook everything up, it's talking about different types of resistances and microfarads from capacitors, and you can change the frequencies and the sounds based off of what capacitors and resistors you actually connect, and that's what this is trying to explain to you. So when you look at this, you get a schematic that shows you how the whole circuit's supposed to be wired up, and because we're in the first chapter, the whole beginning stuff, it actually shows you your device and how the wires are supposed to be wired up in order to do what you want it to do, okay? So because of that, it makes it a lot easier for somebody when they're first kind of trying to learn how to use this. Now to give you an example though, when you get past chapter 1 and you start getting into chapter 2, which is your basic electronic circuits, you're going to notice they take that diagram away that shows the actual device, and it only goes off the schematic and the wiring sequences. And it still shows you information based on the experiment that you're doing, as you can kind of see here, okay? Now, I'll make a video, or multiple videos actually, that has to do with how to set up each individual experiment in this program, okay? So, I guess you can say I'm going to make a series that has to do with the Electronic Playground 130 and every single experiment that you get to go through. And I'm going to show you step by step on how to hook them up. But for this video, I'm just kind of give you an overview or a demonstration about what the device is, what it's supposed to do, and generally how you set things up, okay? So what's going to happen is I'll reset you guys up so you can see the device, and we're going to be doing experiment number 1, which is... Okay, so now I got my device all set up so you can see. Alright, as you already know, we got the batteries installed, and I have the manual flipped to page number 12 for our very first experiment, which is the Woodpecker. Now, I'm going to want to get my bag of multiple wires, and by the way, don't worry about if you're using wires that are too long and stuff. If you happen to choose a wire, and you're going from point A to point B, for example, like our very first connection with this is going to be spring number 1 right here, okay? Over to spring number 29 to our speaker right here. So if you happen to choose a wire that's just way too short to make it to here, choose a different wire. That's how simple it is, okay? You can even have the longest wire. It doesn't matter if it loops way around or all the way down and stuff. As long as the connection's being made, it's not interfering with other connections on this device, you're going to be fine. Another thing to note too is in the battery section right here, the majority of the battery connections, minus the negatives might be connected early in the sequence, but the positives and such won't be added until towards the end, okay? That's the key thing. Like, for our Woodpecker, let's see here. Yeah, 121 to 122. 122 is our 4.5 positive volt right here, alright? That's the very last connection that's being made. So 121 to 122, that's here to here, alrighty? So I wouldn't really worry about that virtually at all, because that's what's completing the circuit to make it actually work, alright? And that's important too, by the way, because you don't want to complete your circuit with power until everything's set up, because again, unless you make some minor adjustments so you have your key or your switch to be able to turn the circuit on or off, you're unable to make the circuit work without damage. And what I mean by that is if you hook up your batteries and you start hooking everything else up, you might start causing damage to your transistors or to your ICs or to a capacitor or so on. So remember, don't hook your power up until the end. And the book's wiring sequence actually works that way, so you don't have to worry about it right away, okay? Especially when you're just learning. But let's get started. And our first one, we need to wire number 1 to number 29, just like I mentioned before. So number 1 right here is going to get wired in. So let me get you zoomed in so you can kind of see what I'm talking about. Okay, now you can kind of see the spring a little better. So we're going to push this to the side so it opens up. And we're going to put our wire in any of these little slots or holes. Make sure you go all the way in, alright, up into the insulation. And then give it a tug. Look, it's holding up great. That's how you're going to connect all your wires from every single spring point. There is going to be no difference in that. So let me reset you back to where we were, and we'll continue on. Okay, now you've been reset. So, we go 1 to 29, and 29 is our upper point of our speaker. Now, it doesn't show on the symbols or anything like that if this is the positive terminal or the negative terminal. I'm going to go ahead and assume this one's our positive terminal, but I'm not really 100% sure on that. We just need to connect it that way, the way the diagram showed us, okay? So there, we went from our transformer pin 1 over to our speaker, which is most likely our positive lead of our speaker. Now our next thing is we need to go from number 2 to number 30. Number 2 to number 30. I got a whole bunch of wires that are falling out on me. So okay, number 2 to number 30. So number 2 on our transformer here. over number 30, which is the bottom part of our speaker spring, which I believe is our negative. Without opening up the device, I really can't tell you if this is a positive or a negative, okay? That's kind of how it comes down to. Because it doesn't show in here and it doesn't say in the book. Alright, so our next one is going to be spring number 3. That goes to spring number 104. So our transformer spring 3 right here is what is next. Alright, sometimes it can be a pain in the butt. It depends on how much you've used your wires. Like I mentioned before, it shows you can go ahead and strip your wires down. Which, by the way, I recommend if you do strip your wires, you should tin them. Which you'll find some information on that in my how to solder video that I'm going to be creating soon, okay? Alright, so we're kind of connected there. We should be good. So, pin number 3 goes to pin 104. And 104 is right over here. Now, see how my wire is not quite long enough? Like I mentioned to you before, sometimes, you know, your wire's not going to be long enough. Well, that just means you got to choose a different wire. So let's find a wire that's longer than what we had there. This one might do. So let's hook this up. Pin 3 to pin 104. And look at that. It's just long enough. Okay. So there's that. And then we need to go from pin 104 to pin 106. This one, we can obviously use a much shorter wire because we're going from here right to here. So 104 to 106, we got to find a super short wire for. And again, if you don't have a super short wire, it's fine. It's perfectly fine. Just use whatever wire is going to work without causing a short or anything like that between other circuits. So we'll get this one in here. Okay, so we got that hooked up. Now, we're going to go from pin number 4 to pin 28 to pin 124. So, first, pin number 4, which is right here. Oops, I'm sorry guys. Which is right here on the transformer. Alright, so we'll see if this one will reach from pin 4 to pin 28. So we'll put this wire in here. Okay, now we got to go to pin 28, which is we got to figure out where these pins are all located at. Okay, pin 28 is the control. As you can see, I barely have enough wire to be able to make that reach, so I'm not going to use the blue wire. I'll use a different wire. Okay, so let's see what other wires I have. Let's try this yellow wire. Okay, and then we're going to go to pin 28 on the control knob here. Alright, so pin 28 is right there. There we go. So now we're connected to 28. Alright, so now you have the basic idea about how all these are supposed to be connected by actually using the springs and such. I'm going to finish all the connections, and then we're going to come back and finish it up, and I'll show you the woodpecker, okay? So we'll be right back, guys. Stay tuned. Okay, now as you can see, this thing has a whole bunch of wires, literally all over the dang place, okay? And it's set up. All we have to do now is run our wire from our negative post over to our positive on pin 122, okay? So, I'm going to go ahead and hook up the power, and you're going to hear what they call the electronic woodpecker. You hear that? That's what they call a woodpecker. The woodpecker call. Now, right here on our control, alright, this is a variable resistor, and it's in our circuit. And as we increase the resistance going up from 0 to 10, you're going to hear a change in the pitch. See that? We're changing the resistance flow that's going within the circuit itself. So that will cause the actual circuit to change its pitches. Now if I were to remove the yellow and orange wire here on pin number 28 and move it to pin number 26, the only difference that's going to make is it'll flip the resistance. So when you are technically between 0 and 1 like we are now, you're going to actually sound like you're at 10. Like that. While at 10 being flipped, it's going to sound like it is right there. Okay? Now, we'll turn that off. But one of the things I'm going to show you that you can do differently, as you saw when I hook 121 to 122, it automatically starts up and there's no on or off. So what I'm going to do is I'm going to hook it up so that the switch right here actually turns the circuit on and off. So the first thing I need to do is take one of my wires, typically like a medium to long wire, so I'm going to use the blue wire for both. I'll set up on 121, just like so. And then I'm going to go to 132. You could also use 135, but just remember, these center pins here, these are input pins, okay? And then the outer pins are output pins. So if I have my input at, say, 132 right here, then I put an output on 133, the switch needs to be in the down position to make that a fully closed circuit. If I put it on 131, I need to switch up in order to make it a closed circuit. So I'm going to use 132 and 131. So I'm going to put my negative, which is 121, over to 132. Alright? And then I'm going to go from 131 right here, like so, up to our 4.5 volt lead on 122. Alright? So we'll get that hooked up. As you can tell, it has no sound like it was before, until I flip the switch. See? That's kind of what they're talking about by making your different experiments. You can also do the same thing down here with the key. See if I can't readjust that a bit for you. Now this is just a momentary switch. So as you hold the switch, you're going to close the circuit. Alright? Once you let it go, it opens the circuit so it doesn't work. And in this scenario, all I'm going to do is take 121 from right here and put it on one side of my key, or my switch, which is 137, and then I'll take my pin 122, which is my other voltage, and 131 for my switch. So 131, I'll change that over to 138. Now, you see there's nothing going on, right? Until I hit the switch. See? And then from here you can make adjustments. There we go. So, that is the basics to one of these Elenco Electronic Playground 130s. We're not going to go into the next experiment, okay? I'm going to go ahead and start making some videos, and I'll release them randomly, just very short videos on how to set up the different types of experiments in the manual that comes with the entire system, okay? And then, of course, I'll also take this manual, and I'm going to scan each and individual page into a PDF form, and eventually, when I have it all completed, it's going to take me a little while, I'll upload that for people to download. So if you say you happen to find one of these at a garage sale or online and it doesn't come with the book, well, now you have access to the book. So, other than that, guys, thank you so much for watching. I greatly appreciate it. And this is the Electronic Playground 130.